Here we go. As I told you before, like distance between point and line problem is the most complicated problem in projection part, okay? But in another video, like I explained everything, okay? And also like I used like 4 simple steps, okay? And please try to understand the concept to use the like vector projection, okay? And scalar projection, okay? Here we go. So, okay, let me give you the like figure of this one and I will show you like 4 steps to get the answer, okay? Like your given line is 3x minus 4, the y-intercept is like down there, and slope is 3. It's kind of this one. I'm not sure exactly, okay? It is not in a scale, but like something like that, okay? And your point is 1, 2. Maybe somewhere, somewhere here, I think. But it doesn't matter, okay? Let's say it is P, 1, 2, okay? So as you understood before, like we would like talk about the distance between this point and perpendicular foot. This guy. That is the distance D. Is that clear? Okay? So now, let me show like 4 simple steps, okay? Step 1. You need to find the direction vector of given line, okay? So here we go. Okay, let's say it is vector A, okay? But keep that in mind. The direction vector of line is really like, you know, same thing with the slope, okay? So we can start from what is slope of this one, okay? Slope of line is definitely 3, right? As I told you, this 3 means 3 over 1, okay? So 1 is run, which is in an x component, and 3 is rise, which is y component, okay? So from this idea, I can write your direction vector A as 1, 3, okay? Let me come back to the problem, okay? 1, 3 is here, somewhere, okay? But let me start from here, okay? This is vector A. Is that clear? Because we found like direction vector of line, okay? And then step 2, and we're gonna try find the orthogonal complement of A, okay? So we notate by A orthogonal. How can we find it? Switch x and y component and the opposite on your x component, okay? That's okay. What is the meaning of like geometric meaning of this one? That is exactly just 90-degree counterclockwise rotation, okay? So like your A is here, then your A orthogonal is here. Is that okay? But as I told you, like all the vector can be moved anywhere, okay? As long as like it is the same length and same direction, they are all same vector. So like let me move like your A orthogonal to here. Then like I will match with this point, which is perpendicular foot. So can you see? That's exactly overlapped like this one. Does it make sense? Okay. This is second step, okay? What is step 3? Step 3 is always a little bit tricky, okay? You have to construct like one new vector V, but this must be from point P to any point on the line, okay? So from this point P to any point on the line, doesn't matter, okay? So like for the practice, let's use the y-intercept, okay? P to y-intercept, okay? Which is 1, 2, the y-intercept is 0, -4, okay? So which means your vector B is equal to 0 minus 1 and -4 minus 2. Is that okay? So basically, like that vector is what? from here to here. Okay, can you see like this right triangle? Okay, now what we're going to do is like this is vector V, okay? And we're going to project vector V onto a orthogonal. Does it make sense? If you just like, because like that is the right triangle, I mean like, right angle, like if you project your vector B onto a orthogonal, that will be exactly this part, which is the distance between the point and line. Is it okay? Here we go. So now we're almost there. Let's do step 4 here, okay? Your distance D can be calculated by scalar projection B onto a orthogonal, okay? But keep that in mind. As I told you, it must be absolute value. Like just in case if you have negative value, don't worry about it. Make it positive, okay? That is equal to a orthogonal dot B over the length of a orthogonal. Again, absolute value, okay? So let me keep it, okay? What is a orthogonal dot B? A orthogonal is here and B is here. Negative 3 times negative 1, which is 3, and 1 times negative 6, which is negative 6, over the length of a orthogonal, okay? Negative 3 squared plus 1 squared. And again, absolute value. Okay? It is equal to negative 3 over the square root of 10 and absolute value. So finally, the distance D is equal to 3 over the square root of 10. This is the way to use the projection to find distance between point and line, okay?